But one thing that is going to remain constant throughout, though, that thing is connectivity. All of these elements and all of these compute elements are going to be effective when you put more and more of these together and make them work as a single system.
On this episode of Embedded Insiders, Aravind Srikumar, SVP of Product Marketing at Upscale AI, joins the podcast to discuss how the company is tackling both scale-up and scale-out networking, why it's important to address both sides of the networking equation, and today's requirements for an AI-optimized network. Next, Rich is joined by David Sandys, the Senior Director of Technical Enablement and Engagement at DigiKey, with a recap of Embedded World. But first, Ken and I are talking about the advanced packaging trend and how it seems the industry is shifting from the traditional chip scaling approach that is Moore's Law. Hello, everyone, and welcome back to the Embedded Insiders podcast. I'm your Assistant Managing Editor, Tiara Oliver, and I'm here with our Editor-in-Chief, Ken Briota.
Hello, friends. Good to hear you again, Tiara, and to be talking toward our wonderful audience of engineers and designers out there.
So I guess I'll kind of get right into the topic. By no means am I an expert in this topic, but I was just doing some scattered, I guess, research and Googling online and came across just the topic, which is nothing new, of course, in our industry, but it's about advanced packaging, and kind of just this idea of how, maybe not exactly, but how people are starting to think less about Moore's Law and more about advanced packaging as far as chip companies, and how this innovation is moving from scaling down or shrinking chips or transistors and instead kind of stacking them.
Yeah. It is interesting because obviously, packaging has been in a lot of ways the driving force behind keeping up with Moore's Law. One of my favorite aspects of it lately that people have been talking about is the chiplets.
Yes.
Sort of stacking structure and modularity. I think that's so cool. I think the customization inherent in using chiplets is really neat. Because so many times the custom solution is the right solution, even at scale for a given application. And a lot of the smarter semicon companies and manufacturers are realizing that and leveraging good packaging, whether it be IC stacking or chiplets or whatever, to make those customizations happen. So I think it's really cool.
Yeah. And when I first started in this industry, of course, Moore's Law was a new concept to me, and I was hearing about it a ton, and it just seems like we're hearing about it less and we're just hearing more about advanced packaging, which is obviously the role of AI and high performance computing is obviously, part of driving maybe this shift. I don't know, but I think it's interesting how we're now moving into 2D, 3D stacking, like you said, chiplets, and then even integrating different parts of a system like memory and things like that. Yeah.
I think I'm a big fan of this modularity that we're seeing in the sort of purpose-built design trend that, to me, is the sign of a mature and maturing marketplace. For which is a good sign for stuff like edge computing and embedded edge and a lot of the AI systems and the sensor fusion stuff, all of which is, well, it depends on who you talk to, newer than some other stuff, but this sort of less talk about, descriptive things like Moore's law, and more conversation about sort of practical engineering, solutions driven discussions like we're finding with advanced packaging. I think it's really positive. I think it's really cool.
Yeah, and even while I was, looking online, it just kind of seems like advanced packaging is just a new way the industry is moving forward and improving. And I don't know if it's true, but it just sounds like some people are thinking that shrinking chips and things, it's not enough anymore.
Yeah.
So I think it's an interesting topic. I think it's interesting how the trends will continue in the industry in the next couple years. And I mean, this kind of sounds like a trend. I don't know, but I just thought it was something cool to bring up and
Yeah.
talk about.
Yeah, I think it's definitely bears watching, and we certainly will be. You better be careful. This kind of trend identification stuff is going to become your beat, and then I won't have to do it anymore.
Well, if I can find someone who would love to speak about this topic and just the overall idea or this overall trend, I think it's cool. Of course, as journalists, we have to keep up with the trends, and even if we don't have a ton to dive into, I think it's a good thing to bring up and keep everyone thinking.
Oh yeah, absolutely. So that's an invitation out there, open invitation. Tierra wants to talk to you about advanced packaging and chiplets, and how that's intersecting with efficient and embedded computing. So reach out if you think you or your colleague would be a good guest here on Embedded Insiders.
Yes, let us know. Our emails will be open, or my email will be open.
I appreciate you saying that, but mine is, somewhat to my dismay, always open.
Now, here's Aravind Srikumar, SVP of Product and Marketing at Upscale AI.
This is Aravind Srikumar. I do product and marketing for Upscale AI. Before this, I was at pretty much every single networking company there is in the past couple of decades, working with specifically hyperscalers. Did a lot on the operating system side. Introduced Sonic as an open source operating system option at Cisco. True believer when it comes to open source, open standards that enable heterogeneous compute and allows innovation to accelerate. So that's me.
Awesome. So it's been noted that for decades, networking has followed this one size fits all model. In your opinion, what do you believe specifically needs to change in those traditional architectures when they're applied to more modern AI workloads?
Yeah, so I want to take a step back and actually validate the statement of whether if it's one size fits all, or is it too broad of a sentiment, right? So if you divide the networking era, at least from 1995 onwards, from 1995 to kind of 2005, a decade that passed by. That's when networking caught on wildfire. We were trying to connect the desktop computers and offices and make sure that the office is functional, people can communicate within campuses and branch offices. So I call that an AI era, right? And there's one company which did most of the innovation when it comes to networking. We all learned from that company. That's called Cisco, right? And Cisco is a very big leader in the space, and everyone started learning with Cisco as well, right? So that network era required a breadth and depth of features, and it prioritized few things where the bandwidth was not the most important aspect. Latency, a little bit more latency could be tolerated and whatnot. So essentially, that was the advent of networking. feature functionality was very, very important. The operating systems and the networking hardware were tuned to that, right? Fast forward from 2005 to 2015, that's when, all this era is kind of roughly speaking, it's not exactly mapped to that particular 10 years or decade, but in order to draw references and create a compartmentalization of how we have evolved in networking throughout. If you look at the 2005 to 2015 era, internet service providers and connecting large networks and large campuses together was a big notion that was happening. And that required a different set of characteristics because internet required scale very different from enterprise. Internet required ultimate reliability. Internet also required networking to focus on traffic engineering because getting through the network in the most efficient manner mattered quite a bit, and it still matters, right? And there are other networking companies that came in and contributed to the advent of internet. And fast forward 15 years or 10 years, 2005 to 2015, 2015 to 25 is where the cloud and hyperscalers boomed. This required a different notion altogether because we were building lots and lots of data centers. Data center networking is very different from internet networking. And all these eras point to what is the major movement and what is the major evolution in networking, right? So the 2015 to 2025 essentially was the advent of an era where we concentrated on large-scale data center networks. It's more of a client-server architecture where people were accessing a lot of information out there in a data center. And there were several technologies, and this technology evolved to a claw architecture that we see in the network, and the operating systems and the protocols were tuned to that. Through the years, what we have seen is through these 3 decades or 3 eras, we've seen networking transform, and certain architectures were highlighted and essentially served all 3 decades. Now, through these transformations, we started from a networking operating system and network that needed a lot of features. Then we focused on different ideals when it comes to internet. Then when it came to data centers, the feature set was different. Bandwidth, latency, and all of that mattered most, right? So through the eras, what we have been doing is we are creating networks that are specifically focused for that particular traffic that we are serving. Like that, in future, what we are going to see, and starting from 2025 onward, what we're going to see is essentially a network and networking that is predominant or dominated by AI traffic. The reason AI traffic needs a different network is because it just moves differently. It's not a client-server architecture, which you see in the cloud or in general data centers. It is more of a collective communication. So just to compare and contrast a very, very high level, until AI, collective communication, where in which a bunch of distributed systems trying to behave as a single entity or a machine was not the dominant trend. It was more of a client-server architecture, and it had different characteristics. The traffic was more north-south, even though the data center application needed east-west, but it was dominated by the applications that are being accessed north-south. But here in AI, if you look at specifically training, what is happening is the traffic is just moving differently. It's between machines in the same data center. And one significant difference is all of these machines might be physically different, but what we are trying to achieve as an effect by letting these machines communicate is collective communication, which means it's a lot of synchronization. There isn't this clear notion of server and client. So what is needed is the assumption that the underlying network is supposed to be lossless. This is the first event that is happening in the networking industry, which assumes and which requires the network to be lossless. Latency is super important. But this requires a complete rethinking of the network. which means it translates to everything that you do from a software, silicon, and hardware perspective, because people are predicting that this AI networking is going to be a huge market. And once it becomes a huge market, every single system has to be optimized. One question that I ask most of my people in my company, as well as the customers, that I also hear from the customers is, if you look at the AI clusters, everything is specialized. You predominantly don't run training or inference on a CPU, you run it on a GPU. There are specialized chips. If you look at the landscape, why should networking not be specialized? Because networking is no longer a separate entity. It is a part of what makes the AI clusters work. And I think these are the reasons we are looking at a paradigm shift in networking, where networking is going to be super specialized and purpose built to serve a cluster of computers, and this notion of the cluster to be unified, where we allow for multiple GPUs or multiple XPUs to communicate through the same network. And that can only be enabled by open protocols and following open standards.
Okay. So Upscale AI is tackling both scale up and scale out. Why is it important to address both sides of these networking equations rather than just optimizing one?
Yeah, so even though scale up and scale out evolved differently, they are in a means trying to achieve the same thing. So scale up can be defined as a network where the GPUs within a rack or a couple of adjacent racks try to communicate with each other, behaving like one large unit. Scale out is the interconnection of racks, multiple of these racks, because you need the compute power, which cannot be sustained or contained within a couple of racks. You distribute it across the data center. But in both scenarios, you're trying to achieve a similar purpose, where you're trying to make all these discrete components and discrete computers and discrete memory behave like a coherent single unit. This is where the collective communication comes in. So if you look at that specific item, even though we call it as two different things, from a customer standpoint, they are trying to achieve the same thing. Now, having a different system for scale up, having a different system for scale out, even though the end outcome is going to be the same, it's just going to increase the operational complexity of what the customer has to deal with when it comes to achieving an outcome. So what Upscale AI focuses on is to remove this operational complexity that would otherwise be seen by not having the same system or same operational principles across scale up and scale out domains. We do not focus on scale across today because we certainly believe that the AI efficiencies are gained in the scale up and scale out by providing a unified system, which can work. When I say unified system, the software philosophy, the philosophy in which the software is delivered, is a single software that runs across scale up and scale out. So you operate it as a same manner across scale up and scale out, and it gives you a visibility as a single pane of glass, silicon that is optimized for individual workloads, and the systems that are built around it. So what we're trying to do is essentially remove the operational complexity that would come in by connecting large clusters, by providing just one touch point and a single pane of glass to work with, so that the customers can really focus on bringing in the GPUs and compute, and network becomes a very seamless integration point, and all of this combined together comes across as a single cluster to be managed and operated. So we focus on both these solutions, provide the same experience to the customers, so that the customers can really bring in their compute and all the algorithms that they run on top of it to achieve the best outcome possible.
Sounds good. And you also emphasize different open standards. So why is interoperability becoming a more critical requirement rather than, I guess, just a nice to have?
Yeah, that's a great point. A great question. Thank you for asking this. So at Upscale AI, openness is equal to speed. What heterogeneous compute is going to enable in the future is essentially there's going to be in the future multiple different chips that are specialized in a lot of applications and operations. When you have multiple different kinds of GPUs or XPUs that are doing different parts of your same job that you're trying to achieve, then what you need is a medium of communication which is understood and available to every single compute, no matter what the color of the compute is, what's the capability of the compute is. You can see that from the leading GPU vendors producing chips or AI chips that are specifically focused on a particular job or part of the job. For an example, if you look at inference, there is prefill and decode. There are different GPUs and XPUs that are employed within the same task for different purposes, right? So this just points to the specialization that you're going to see going forward. There's going to be much more and more applications that are requiring specialized compute. But one thing that is going to remain constant throughout, though, that thing is connectivity. All of these elements and all of these compute elements are going to be effective when you put more and more of these together and make them work as a single system. And the underlying fundamental that makes this happen is networking. And if networking has to work across an ecosystem of XPUs and GPUs to enable the efficiencies that you gain through it and enable the customer experience the customer is looking for, it has to be heterogeneous, and heterogeneity can only be enabled by following open standards. Again, open standards is essentially the underlying fundamental that is going to enable heterogeneous compute and different compute elements to talk to each other in the future and achieve larger and larger clusters. And open standards is not just in the protocols. Open standards should be across the stack. When I say across the stack, across the networking stack, it should be starting from silicon, systems, and software that enables heterogeneity and interoperability. This also gives investment protection to the customer, because when a customer is making this buying decision on which network to choose and how to best go about building a network that not only serves the needs now, but also in the future, the customer should be able to look at a protocol or a networking stack that allows not only for communication between endpoints today or clusters today, but in the future as well. So investment protection is a very, very essential and underlying principle when it comes to open standards. Upscale AI participates in UAL, UEC. Our operating system is based on open source Sonic. So in every single networking component through the stack, we focus on openness to truly enable heterogeneity and give peace of mind to the customers that the network that they're building today are going to not restrict them from connecting anything that they wish in the future that follows the standards.
Amazing. And I wanted to, go into your collaboration with NVIDIA. Just wondering how your collaboration and the integration of Spectrum X and Sonic change what's possible for AI networking at scale.
Yeah, so we are super excited about the collaboration with NVIDIA. Our collaboration with NVIDIA, we have announced, is based on Spectrum X silicon. So we source the silicon from NVIDIA, and Spectrum X is pretty well known in the AI networking space, one of the most important silicons that we have in the industry that was purpose built for AI. So if you look at that notion, Upscale AI is purpose built. We only focus on AI networking, and we are happy to partner with NVIDIA on a silicon that is super focused on AI networking, but follows open standards, right? So Spectrum-X has Ethernet, allows heterogeneity in computing, and Ethernet is one of the most important connectivity protocols that we follow. And Spectrum-X allows us to optimize, as we spoke about the different errors, allows us to optimize the network and the entire stack and stay true to this pure play networking fundamentals that Upscale AI is based out of. The collaboration is to build systems. So we haven't announced the product lines or specifics about the software yet. So I'm going to refrain from talking too much in depth about those two. And please stay tuned.
Yeah.
Announcement is going to be around the corner, coming soon. There's a lot of exciting things that we are working on, but at the overall level. We have Spectrum-X to be the silicon. We are building systems around it. Again, we have a free hand in building systems when it comes to AI, because we're not focused on any other technology except networking for AI. So we are optimizing the hardware stack to suit the AI data center specifically. If you look at, and I often get this question about what would that might be. So just a very, very high level, if you look at the general cloud data centers, the cooling is predominantly air. What we're looking at when it comes to AI is liquid cooling. So there are a lot of efficiencies that you gain by honing in and making that the design choices that you can make to optimize the hardware. So we are doing that, and not just in cooling, but also some other specific things that we can tune to produce the best efficiency and connectivity to the customers in such a manner that it's interoperable. Then looking at the software, what we are doing is we are taking, again, an open approach there. We are based on Psi and Sonic, and we are introducing principles that really are specific to AI. For an example, telemetry is absolutely needed and mandatory for AI. It should not be an afterthought. So wherever we can enhance and contribute back to the Sonic community, we are doing that. So if you look at the entire stack of the systems that we're going to generate, it's going to be based on Spectrum-X. It's going to be based on Ethernet, which is an open standards. The hardware is going to be purpose built for AI in such a manner that it's interoperable with the infrastructure that is out there. And the software is completely open as well, but we are adding things that optimize the software specifically for AI. Staying true, even with the principles that we have defined, which hone in on openness, allowing heterogeneity, as well as purpose built for AI. It is very easy to get swayed by saying I'm optimizing it for AI and putting a lot of constraints to the customers. We don't believe in that. We are taking a measured approach and a balanced approach, making sure even though we are building things that are super optimized for AI, but a big focus on open and interoperability. So this is what we are working on. The announcements are going to come soon. But one other additional point that I want to mention is Spectrum-X is, as I said, as far as I know, one of the most important and amazing silicon that's out there that was purpose built for AI, right? So now customers have a choice to deploy Spectrum-X in Ethernet networks along with Sonic and bring connectivity to the masses and truly enable heterogeneous compute, right? The Spectrum-X is going to be completely interoperable with every networking or GPU stack that is out there and or NICs as well, right? So the entire stack should be interoperable, heterogeneous. That is one of the things that Upscale AI is going to contribute to, where we are going to produce reference designs that show interoperability and performance improvements across different components in networking, starting from NICs, GPUs, and working with other equipment that might be out there in the data centers as well.
Awesome. Well, thank you, Arvind. I believe those are all the questions I have for you today. But as always, I will advise the audience to just keep up with what you guys are doing and keep an eye out for that announcement that you said is right around the corner. But yeah, thank you so much for joining the podcast today. Is there anything else that I might have missed or anything else you'd like to add?
Yeah, I would request. So this is a big movement that is happening in the AI space, and networking being the crucial element that ties all of this together. This also means that the contributions from everyone matters, right? So not just we're networking vendors, but not just the customers, but also the technologists. Since Upscale AI is on this journey of doing things in an open and interoperable manner, and we are going to utilize the open source tools wherever possible out there. We are contributing as well, and I would request everyone to contribute and collaborate with us. This is a journey in which we are building solutions together to enable true heterogeneity for AI in the future.
Now, here's David Sandys, Senior Director of Technical Enablement and Engagement at DigiKey.
Good afternoon. My name is Rich Ness. I am with Embedded Computing Design. This week, my guest is David Sandys, and he is the Senior Director of Technical Enablement and Engagement for DigiKey. How you doing, David?
I'm doing great, Rich. Thanks for letting me be here. Looking forward to the discussion.
Very good. Same here. So I know we were both at Embedded World a couple weeks ago, and we literally crossed paths and didn't get a chance to chat. So why don't we start there? What did you see that? Yeah, right. What did you see there that really caught your eye?
You know, there were a few things. Unfortunately, as you know, it's such a huge event. You never get a chance to see everything you'd like to at those conferences. You're always spending time, meeting people, learning new things. But I'll tell you, there were a couple things that did catch my eye that were a little unique and different. One was a company called Signaloid. I don't know if you saw them at all. They actually created complete systems, ecosystems, MCU, memory, sensors, and all that in an SD form factor. And so you think about SD card form factor, I should say. So you think about applications for something like that. You could have something running an embedded system, especially in the industrial side of the equation, and then all of a sudden add functionality just by throwing in one of these little SD cards and to a memory slot that they already have there. So I thought that was kind of a neat thing. I will say one of my favorite products that I saw at the show by far, and this is maybe of interest to your listeners, may not, but is this the BeagleBoard Zepto board. So I don't know if you saw that, but it's literally the size of a postage stamp. And what I like about that is it's got that new TI MSP M0 product on it. It's got an RGB LED. It's got a micro bus on the back, so you can expand it for things like rapid prototyping, what have you. It's powered off of the quick connector. So it doesn't even have like a separate USB port for power or anything like that. It's just a really cool thing. And honestly, it's like I think they're trying to get it to about $1 resale for people to be able to utilize it. And so I think that's really neat. And then you can go all the way to the other extreme. I really like that. I don't know if you saw it, but the Infineon PSOC Edge HMI platform. So this is really cool with a 480 by 480 screen on it. It enables people to do AI and ML learning on the platform itself. But it's really a great little enclosed ecosystem by itself. Still expandable through things like the microbus on the back and things like that. But what we're finding is, and that's one of the big elements for big thought topic leaders for thought leadership activities for 2026 is obviously around Edge AI. And so this is one of those platforms that I think will do really well there simply because it enables people to do things quite easily, quite rapidly, leveraging the PSOC environment. So yeah, there are lots of cool things. Lots of cool things.
I actually shot a video in the Infineon booth about that board that you just described. So I did say it was cool. And for the folks listening, if you hop over to Embedded Computing Design, you'll find a link to the video I just referred to that about the board David was talking about. So let me take a step back and make sure people understand what we're talking about here. What's your role at an embedded world? Why would a distributor have interest in what's going on there?
It's really the only place where we can get in touch with our customers on a mass level at scale, and really sit down and understand what are their needs, what are the technical offerings from our suppliers that are coming out for the next year, and how are we going to make those two, intersect. So the ideas are, how do we take the technology leadership that our companies, our suppliers are creating, and bring it out to our customer community? And we did that through various demos. And one of the differences between DigiKey at the event and other distributors that are at the event is we had a whole tech bench area where our applications engineers, our technical marketing teams created demos that are unique and different, not leveraging just what suppliers are creating, but things that we think our audience, that would resonate with our audience. So we had some things out there, not just like STM32 and 6, facial recognition, hand gesture recognition platform, but then we take it to the next level where we actually have a game that it's playing, and it'll recognize, you can tell it to start a certain game, and certain hand gestures will do certain things. And you really get to understand what are some of the things you can do when you have on the edge that compute power and capability. We also had things out there like a machine chat demo that was leveraging the Arduino Uno Q. So the Uno Q is kind of one of their new platforms. We'll talk maybe a little bit. We'll get to the Ventuno if we've got some time to talk about what that one is. But the Uno Q, what makes it so unique and different is if you think about it, it's kind of like a mixture of an SBC, a Raspberry Pi type platform with an STM32 on it as well with a microcontroller. What that gives you is the ability to have things like machine chat. Machine chat is a program that does data aggregation, data visualization. It does that all on the SBC side of the equation, while leveraging the sensors through the Arduino side. Why this is so important is because a lot of companies and even schools and other places want to keep their data on premises. They don't want to have the data go up to the cloud. And so by having something like machine chat running on that board itself, you can get all your data visualization. You can see what's going on with the sensors on the platform, but you don't have to do references up to the cloud and interpret on the cloud and have your dashboards leveraged off the cloud. And that's kind of one of the cool things you get there. So DigiKey, by having all these, a plethora of different suppliers, we can aggregate all those and create something that's unique and different at the event, as opposed to a single supplier that's going to talk mostly about their platforms. We talked a little bit about Infineon and the PSOC Edge HMI board just a few minutes ago. Well, while that's an interesting platform, there's no customer in the world, and we wish they would, that would design 100% with Infineon. They're going to want sensors, maybe, let's say, from a Bosch or Sensorion, or Sensomatic, someone else, right? So that's what Digi can bring to the equation. And when you look at, for instance, we had a thread demo, we had platforms in there from NXP, we had platforms from other vendors, from Microchip, all in one platform that actually work together to talk about thread and what you would utilize in thread, how you can put that in an embedded environment, and how our customers can leverage that for rapid prototyping. And that's what we're trying to do at the event.
So you spoke earlier about Arduino, and I'd like to go back to that a little bit. If you're a member of the design community, and now this Arduino that you've come to know and love is now part of Qualcomm, what does that mean for an engineer?
I mean, I think it offers an unprecedented amount of flexibility and new performance gains that you just were not going to get by an Arduino by itself. So, one of those things that you have is you have these environments like a Raspberry Pi, which is an incredible platform for rapid prototyping, but it bringing on traditional embedded sensors to that equation is a little bit of a challenge. And so what that means is that, leveraging this type of environment where you've got both of those two things together, you've got the SBC side of the equation, plus the real-time environment of the microcontroller, it gives that unprecedented, single platform view of that data manipulation, the data aggregation, and what have you. So it's really unique and different. And obviously, some of the challenges that originally happened is, how do you deal with this from a software standpoint? And App Lab is a really good example of them taking the first approach of making that work, where you've got these canned programs that are out there. But now I think they've taken it to the next level. The Ventuno Q, if you've seen that one, I don't know if you've played around with that platform yet or not. I've seen it a couple of times now in the wild, and it's an amazing board. And that gets you now 40 TOPS. It gets you a device that's got an NPU, a GPU, and a CPU all in one platform. It's got 16 gigabytes of memory, 64, I should say, in eMMC. So there's a lot of things that you get from that platform that will enable unprecedented levels of performance to the masses. And that's one of the things that get. It's funny, Rich, when you and I first started talking, an embedded design may have cost thousands of dollars to start, right? I mean, you go back in the history, and now with these new platforms, you're going to get 40 TOPS at a few $100s. I mean, it's just crazy as to where it's gone. And I think that's where it's a natural progression. The good thing is that they're dedicated to keeping Arduino, to its core notion of open source. They're dedicated to leveraging the Arduino IDE. They're dedicated to keeping what has made the secret sauce so special for Arduino as they move forward in the next part of this journey.
Very good. You seem to have done a pretty good job navigating through all the massive hype of AI. Where do you feel we are today with respect to hype versus reality? I know if we had this conversation a year ago, it was way more on the hype side, but where are we today, in your opinion?
I think we're getting there much quicker, especially on the edge. Now, obviously, on the main side of AI, you've got all these new companies that have come out, whether it's DeepX or Halo, with these accelerators that are out there for traditional platforms and what have you. Those are really cool, but it's the edge where I think that where we've made huge strides in the last year. That we talked about the PSOC edge, but there's now coming out all these smart sensors that can do all of the inferencing on the edge. You take a look at some of the things that have come out from companies like Seed Studios, where you have these small little platforms to train models on the edge quickly, rapidly, with a single click. So people are learning how they do inferencing and those types of things. So in such an easy to follow format that it makes it almost, unfortunately, it makes it so easy that it takes a lot of the time out of the equation. So people are making leaps and bounds every month. And I think we're just going to continue to see that throughout this year. I think what you're going to find is that there's going to be more and more focus on the edge. And we're coming at it at two different levels. You've got, like I said, the Halos and the DeepXs at the very high end, the NVIDIAs and what have you at the very high end. I think Synaptics has a really neat platform coming out that they worked with Grinon and a couple other companies. That's the Coral development board. That's a really nice platform. You probably saw that at the show as well, or at the talk about it, at least at the show. And so you're getting the high end coming down, and you're getting the low end coming up. And somewhere in the middle is when that secret sauce is going to be perfect and ideal. We're getting there. I think probably within the next year or 2 years, things are just going to take off. It's almost like, Rich, it's almost like the wireless realm, right? If you think about where wireless was, now it seems like there's a new protocol every week, right? I mean, all of a sudden, you've got DECT NR+, right? So now the DECT, the old cordless handsets, that is now back, right? And you've got YSUN, and you've got all of these new platforms that are all these new technologies that are out there. Eventually, one will win, or a few will win. And we've been talking about Halo, we've been talking about LoRaWAN, we've been talking about these things for a couple of years now. What will happen is something will win out, and I think we're going to get that convergence on edge AI as well. I think you're going to find other technologies that are really neat that are going to help expand utilization on the embedded space. Single pair Ethernet is another one that I think is ripe now that they're starting to really look at having a standardization around the connector format. So these platforms will all kind of be a little bit more plug and play. I think that's going to be critical. So I think standardization is going to be important from that standpoint. But I really think that on the edge AI portion, that's where it's going to be fun. It's going to be, I bet you when we come back here next year, there's going to be not just, one or two or three really interesting sensors. There's going to be like a dozen that you and I could probably take apart and, for a half hour and talk through. And I think that that's going to be fun and unique. I can't wait to see where it goes.
I love that you answered just about every one of my questions without me even asking it. Before we wrap up, I think we need to address the one elephant in the room, the memory crisis. That was definitely something that was very prevalent at the show. And for the most part, nobody would talk to me about it on the record. What's your take? What are we going to do? And does it settle out anytime soon?
You know what? I don't have a crystal ball on that one. So the second part, I'm really not quite sure. I think I'm in the same boat as you are. We hear a lot of different things that are out there. I think though there's some really interesting things happening to help people through this cycle. So for instance, the Raspberry Pi announcing the 2 gig is now they've laid out the board to have 2 1 gig memory modules on it, which or memory devices on it, which is really a neat approach. We're also talking about how do we, take a look at memory footprints and help people shrink them, because there's a lot of times people just buy like an 8 gig device, not realizing that it wouldn't take much to put it in a 4 gig, right? I mean, so I think we're going to find a lot more of that happening, but I think you're right on. It's going to be a little bit more pain, but we're trying to do our best. We have lots of different tools that we're putting out there to help people navigate through what's available. Help people navigate kind of, maybe there are certain places where there are alternatives that will work. The nice thing is that I think everyone realizes that, this is something that we all have to address. And we're working internally at DigiKey to kind of help our customers through it. There is no simple solution right now, though. It just isn't. And it's something that we're going to work and make sure that we have our customers have the least amount of pain as possible.
Very good. Thank you very much, David. That was some great insights.
Thanks, Rich. It was great being here.
That was David Sandys. He is the Senior Director of Technical Enablement and Engagement at DigiKey, and I'm Rich Nass with Embedded Computing Design.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.